All right, today we're going to look at section 10.2, hypothesis test for a population proportion. We're just going to be skimming the information and then we're going to go to MyMathLab. So here are your section objectives. Here is a description of p hat, which is a sample proportion, and they describe x and n right here below. This is what you learned in 8.2. Also, they remind you of the standard deviation, the criteria to check that you have a simple random sample, and to check that it's independent, so that NP 1 minus P greater than 10, and that your sample size is less than 5% of the entire population. Setting up a hypothesis test, so we learned about this in 10.1. The null will always include equality, versus the alternative will either be greater than, it's a right tail test, less than, left tail test, or not equal to, where you have a both-sided test. We test and describe what it means to be statistically significant, and they talk about that a little bit here and going down in this example provided below. Talk about the classical approach, comparing z-values. We got some good reading here. And then we get to start talking about the p-value approach, and they describe what p-value is here. So this is good explanation in the definition. And then hypothesis test using the p-value approach. So in 10.1, I do believe we talked about type 1, type 2 error with the language of hypothesis testing. Remember, type 1, think about court of law. We assume a person is innocent until proven guilty. So I believe type 1 we said was reject the null when it's true, so that would be convicting an innocent person. And then type 2 would be we fail to reject the null, so we say they're innocent when they're actually guilty, so we're letting the guilty go free. So it's worse to convict an innocent person, so we want that to be really, really small. So usually when we assume hypothesis is true, if we don't have enough evidence to prove guilt, then we assume the innocence. So just go back and review those. So here are ways to conduct a conclusion when hypothesis testing and comparing p-value. So it says if the p-value is greater than 0.10, which is 10%, we do not reject the statement in the null. So the sample evidence is consistent with the statement that in the null hypothesis. So if we're between 5 and 10, there's some evidence against the statement in the null, and then the smaller the p-value gets, the stronger the evidence against the null. Okay, so higher p-value is weaker evidence, lower p-value is stronger evidence. So the smaller the value, the stronger the evidence against the null statement. So remember that. We'll see some questions like that in MyMathLab. Then we have hypothesis testing regarding the population proportion. So you have a two-tailed test is equal versus not equal, left tail equal versus less than, right tail equal versus greater. Here is how we compute these by hand, and it shows you step by step using the formulas. Most times we're going to be using the technology to do it. Standard error, again, this is the standard deviation, also known as the standard error. And then here's just another example showing you how to use it, giving you some things to look out for and be careful of. Another example provided here. Again, we'll be doing all of these in MyMathLab, but it's good if you want to see how to do it by hand. This is very good. It's telling you exactly everything you need to know, level of confidence, where they're getting the numbers from, how to get the z statistic, how to get the test statistic, and then here's what we'll be seeing when we do it with technology. So we'll be doing it with StatCrunch. So then we have a two-tailed hypothesis test and confidence intervals. So again, they are describing how to do that. Here's an example. And then they further, give you how we find the null and alternative, using those to compute confidence interval. All right, so that's just an overview. Again, here's at the end how to use technology, calculator, Minitab, Excel, and StatCrunch. So with that, we're going to jump into my math lab and start doing examples.